tried homework 9, number 1, in which we proved theorem 6.1. And theorem 6.1 says every group is isomorphic to a group of permutations. Therefore, for all G and G, we're going to define the group of permutations Tg from G to G by Tg of x, and that's equal to G times x. So in order to prove this, we have to show that Tg is 1-to-1 and onto. So to prove that Tg is a permutation of G, this part A, we're going to show it's 1-to-1. So we said let A be in G and let B be in G. Then we plugged in A and B into Tg, so Tg of A, and we set them equal to each other, equal to Tg of B, which implies that Ga is equal to Gb, and therefore A is equal to B, so Tg is 1-to-1. To also show that Tg is a permutation of G, we have to show that it's onto. So we let Y be in G and let G be in G. Since G is a group, we know that the inverse of G is in G, and we set x equal to G inverse times Y. Then we plugged in x into Tg, so Tg of x equals G times G inverse times Y. G times G inverse is the identity, so we have that's equal to the identity times Y, and then that's equal to Y. So therefore, Tg is onto. And since it's 1-to-1 and onto, we know that Tg is a permutation of the group G. And that's number 1, part A.